Have you ever pondered over the mystery of the universe's dark ages? Imagine a curtain of darkness, impenetrable and infinite, enveloping all that is known and unknown. Such was the state of the universe during the cosmic dark ages, a term that paints a vivid picture of this enigmatic epoch. The cosmic dark ages is not a period of stagnation, but a time of profound transformation. It's a chapter in the universe's history that's as significant as it is mysterious. The term dark ages, while evocative, doesn't imply an absence of activity. Rather, it signifies a time when the universe was opaque, not transparent, to light. This era, nestled between the birth of the universe and the illumination of the first stars, is a testament to the universe's capacity for change and evolution. The cosmic dark ages, a period of profound darkness and mystery, beckons us to delve deeper. To understand the dark ages, we must first journey back to the very birth of the universe. Imagine the universe as we know it, compacted into a tiny, dense point, a singularity. This singularity was so incredibly hot and dense that our current laws of physics cannot completely describe it. Then, in an event of unimaginable power, this singularity began to expand rapidly. This cataclysmic event, known as the Big Bang, marks the beginning of our universe, an event that took place around 13.8 billion years ago. Now, you might be wondering, what exactly happened during the Big Bang? Well, it wasn't an explosion in the conventional sense, but rather an expansion. Picture a balloon inflating with the universe expanding in all directions at once. The Big Bang theory posits that the universe began as a scorching hot dense point and has been expanding ever since. In the immediate aftermath of the Big Bang, the universe was a seething hot soup of particles. Energy was so intense that matter as we know it could not exist. However, as the universe expanded, it also cooled. This cooling allowed for the formation of subatomic particles, and eventually, the first atoms. These atoms were primarily simple ones, hydrogen and helium, with trace amounts of lithium. Each atom was an island, isolated and alone in a sea of light and heat. There were no stars, no galaxies, just a seemingly infinite expanse of these basic elements. It was a simpler time in the universe, a time of potential, a time of beginnings. The creation of these first atoms was a pivotal moment in cosmic history. Why, you ask? Because atoms have a unique property. They can clump together, under the influence of gravity, to form structures. It's the formation of these structures that would eventually lead to the universe as we know it today. The formation of the first atoms marked the end of the universe's babyhood and the beginning of the cosmic dark ages. Imagine a universe with no stars, no light, just a vast expanse of darkness. This was the onset of the cosmic dark ages, a period of time that lasted hundreds of millions of years after the Big Bang. During this epoch, the universe was not the star-spangled spectacle we see today. Instead, it was an eerie, pitch-black void, devoid of the twinkling stars and galaxies that we are accustomed to. This was a time before the formation of the first stars and galaxies, a time when the universe was shrouded in an inky blackness that stretched as far as the eye could see, if there was an eye to see it. But this was not an empty darkness. The universe was filled with a sea of particles, primarily neutral hydrogen atoms. These atoms were the building blocks of the universe, the raw materials from which stars, galaxies, and eventually life would form. But in the Dark Ages, they were just floating around in the darkness, waiting for the forces of gravity to slowly pull them together. Alongside these hydrogen atoms, there was another, more mysterious component: dark matter. Despite its name, dark matter is neither dark nor matter in the way we normally think of it. It does not absorb, reflect, or emit light, which is why we cannot see it. Yet, it's believed to make up about 85% of the matter in the universe. In the Dark Ages, dark matter played a crucial role, its gravitational pull helping to gather the hydrogen atoms into clumps that would eventually form the first galaxies. So, picture this: a universe filled with an almost unimaginable amount of matter, yet so dark and so cold that not a single speck of light could be seen. A universe that was silent and still, yet brimming with potential. A universe where the stage was set and the actors were ready, but the curtain had not yet risen. The universe was a vast, dark sea of particles, a stage set for the next act in cosmic history. In the heart of the darkness, something stirred: the era of recombination. At this point in our cosmic journey, the universe was a hot, dense soup of particles, predominantly electrons and protons. But as the universe continued to expand and cool, something remarkable happened. Those protons and electrons started to come together to recombine, forming the first neutral hydrogen atoms. This was no overnight event. Oh no. This process took hundreds of thousands of years, as the universe cooled from a blistering 5,000 degrees to a mere 3,000 degrees. Imagine a dance, a cosmic ballet of sorts, where particles swirled and twirled, each electron finding its partner, a proton, in the vast cosmic ballroom. And as each pair came together, they formed the first atoms. The universe was becoming less of a plasma and more of a gas, a shift that would have profound implications. Because, you see, in this plasma state, light, or photons, could not travel far without colliding with an electron or proton. But as the universe cooled and more atoms formed, the photons began to find their freedom. No longer were they bound by constant collision and interaction with other particles. They could now travel freely across the universe, no longer bound by the chains of the plasma state. This freedom of the photons is what ultimately led to the creation of light. The universe, once a dark, dense fog, began to clear. These photons, unencumbered and free, began to fill the universe with the first light, a faint glow that would grow over time. The era of recombination was a turning point, a shift from the darkness to the light. It set the stage for the next act in our cosmic story, the cosmic dawn. As the fog of the universe lifted, photons traveled freely, setting the stage for the cosmic dawn. After hundreds of millions of years of darkness, the universe finally saw its first light. Imagine an endless night finally giving way to a spectacular sunrise. This wasn't just any sunrise, but the very first one, illuminating the cosmos and marking the transition from an era of darkness to one of light. This is the story of the cosmic dawn. As the universe cooled and expanded, pockets of gas started to collapse under their own gravity. These pockets of gas became denser and denser, until the pressure and temperature at their heart reached a critical point. That's when nuclear fusion ignited, giving birth to the first stars. These stars were massive, even by today's standards, often hundreds of times larger than our own sun. Their fierce light began to pierce the dark void of the universe, like the first morning rays breaking the night's grip. But stars weren't the only source of light during the cosmic dawn. As more and more stars formed, they began to clump together, creating the first galaxies. These galaxies, filled with newborn stars, started emitting their own light, contributing to the luminous spectacle of the cosmic dawn. The cosmic dawn is not just about the creation of stars and galaxies, though. It's a turning point in the evolution of the universe. Before this era, the universe was a dark and featureless place. But with the cosmic dawn, the universe began to take on structure and complexity. It's like watching a black and white painting slowly fill up with colors and details. The light from the first stars and galaxies didn't just illuminate the universe. It also started to heat and ionize the surrounding gas, triggering a process known as reionization. This process further shaped the universe and paved the way for the formation of even more stars and galaxies. The cosmic dawn marked the end of the Dark Ages and the beginning of a universe filled with light and life. It's a testament to the universe's incredible ability to evolve and create. From darkness, light; from chaos, order; from nothingness, everything. That's the story of the cosmic dawn. The Dark Ages, a time of cosmic mystery, left an indelible mark on the universe. This epoch, following the era of recombination, was a period when the universe was shrouded in complete darkness. No stars, galaxies, or luminous matter existed yet to light up the cosmic landscape. Despite its name, the Dark Ages were far from uneventful. During this time, the first structures of the universe began to form, setting the stage for the cosmic dawn. As the universe expanded and cooled, matter began to clump together under the influence of gravity. These early clumps would eventually give rise to galaxies, stars, and ultimately, life as we know it. Today, scientists continue to study this fascinating period, using cutting-edge technology and cosmic microwave background radiation to unravel its mysteries. Understanding the Dark Ages is crucial for us to comprehend the grand tapestry of the cosmos and our place within it. The cosmic Dark Ages, a period of profound darkness, set the stage for the universe's grand spectacle of light and life.